In the years before the United States fully entered World War II, much of the world had already been consumed by fire. Across Europe, nation after nation fell beneath the advance of Nazi Germany. Cities burned under aerial bombardment. Armies that once seemed powerful collapsed in weeks. By 1940, France had fallen, Britain stood alone, and German bombers darkened the skies over London night after night. Military strategists around the world were forced to confront a terrifying new reality. Modern war would not be won solely by brave soldiers on battlefields. It would be won by the nations capable of producing weapons, vehicles, aircraft, ammunition, and fuel on a scale never before imagined. At the center of this realization was one critical truth: air power had become decisive. Bombers could strike factories, railroads, ports, oil refineries, and entire cities hundreds of miles behind enemy lines. Fighters could defend armies and fleets from destruction. The side that controlled the skies increasingly controlled the war itself, but aircraft were among the most complicated machines ever built. A single heavy bomber required thousands upon thousands of precision-made parts, advanced engines, miles of wiring, hydraulic systems, weapons mounts, armor plating, and highly trained crews to operate them. Before the war, aircraft production had been relatively slow, almost artisanal by industrial standards. Planes were often built in specialized factories by skilled workers in methods closer to handcraft than mass manufacturing. That approach was no longer enough. As Germany expanded across Europe and Imperial Japan pushed deeper into Asia, Allied planners began calculating the scale of the war ahead. The numbers were staggering. To defeat the Axis powers, the Allies would need not hundreds of bombers, but tens of thousands. They would need replacement aircraft for every machine lost in combat, reserves for future campaigns, and enough production capacity to outpace the enemy year after year. The war was becoming a contest not just of tactics or courage, but of economics, engineering, and industrial endurance. Even before the attack on Pearl Harbor in December 1941, President Franklin D. Roosevelt had already begun preparing the United States for this reality. In a radio address delivered in December 1940, Roosevelt called on America to become what he famously described as the arsenal of democracy. He understood that if Britain, the Soviet Union, and eventually America itself were to survive, the United States would need to transform its vast civilian economy into the greatest war production machine the world had ever seen. At the time, many doubted such ambitions were realistic. The US military was relatively small compared to the armies then fighting in Europe. American aircraft production lagged behind wartime needs. In 1939, the entire United States had produced fewer than 3,000 military aircraft in a year, yet military planners were now discussing targets of 50,000 planes annually, and then even more. To many observers, the figures sounded absurd. But America possessed something no other nation could match: enormous industrial capacity. Its factories, machine shops, rail networks, steel mills, oil fields, and workforce represented the largest industrial base on Earth. The challenge was not whether the United States had resources, it was whether those resources could be reorganized and mobilized quickly enough to meet the demands of global war. The transformation began almost immediately. Automobile plants that had once produced family sedans and trucks were retooled to manufacture tanks, engines, armored vehicles, and aircraft components. Refrigerator factories shifted to making ammunition casings. Typewriter companies built machine guns. Shipyards expanded around the clock. Entire industrial sectors were redirected toward war production with breathtaking speed. Yet among all wartime needs, heavy bombers remained one of the greatest priorities. Allied strategy increasingly depended on strategic bombing campaigns designed to cripple enemy industry and destroy the Axis war machine from the air. That strategy required vast fleets of long-range bombers capable of carrying heavy payloads over Europe and the Pacific. Aircraft such as the B-17 Flying Fortress and the B-24 Liberator would become essential to these missions, but building enough of them presented an immense challenge. The B-24 Liberator, in particular, represented both the promise and the problem of modern war production. It was a powerful long-range heavy bomber capable of carrying large bomb loads farther than many of its contemporaries, but it was also extraordinarily complex. Each aircraft required roughly 1.5 million individual parts, sourced from thousands of suppliers across the country. Building one bomber meant coordinating steel, aluminum, rubber, glass, wiring, hydraulics, engines, instruments, weapon systems, and precision machine components into a single combat-ready machine. Under pre-war manufacturing methods, producing bombers at the scale required would have taken far too long. Military planners knew something revolutionary had to happen. Traditional aircraft production methods, slow, specialized, labor-intensive, would never meet the demands of modern industrial war. If the Allies hoped to overwhelm the Axis with air power, they needed to find a way to build bombers not like handcrafted machines, but like automobiles rolling off an assembly line. That idea sounded almost impossible. Many aviation experts argued aircraft were too complicated, too delicate, and too precision-dependent for assembly line production. Unlike cars, bombers had to survive combat, fly at high altitude, and function flawlessly under extreme conditions. A tiny defect in assembly could mean disaster in the air. Skeptics insisted no company could produce heavy bombers in true mass production quantities without sacrificing quality. But the pressure of war left little room for skepticism. As 1941 progressed, the threat grew more urgent. German armies invaded the Soviet Union in June, opening the largest land war in history. Britain remained under constant threat. Japanese expansion in the Pacific intensified. Allied losses mounted on every front. The need for aircraft became desperate. Then came Pearl Harbor. On December 7, 1941, Japan's surprise attack on the U.S. Pacific Fleet thrust America directly into the war. Overnight, every industrial calculation changed. What had been urgent became immediate. The United States was now fighting a two-front global war against powerful enemies across two oceans. Victory would demand not merely large-scale production, but industrial output on a scale unprecedented in human history. Factories began operating 24 hours a day. Millions of Americans entered war industries, including women who had previously been excluded from much industrial labor. New plants were built at astonishing speed. Production schedules became national priorities. Government contracts flowed into private industry. Engineers, executives, and military planners worked side by side to solve manufacturing problems once thought impossible. The war had become more than a clash of armies. It was now a race between industrial systems, between the productive power of the Axis and the overwhelming manufacturing potential of the United States and its allies. And in that race, one question would define the future of the conflict. Could America build enough bombers fast enough to dominate the skies and break the Axis war machine before the enemy could do the same? The answer to that question would soon emerge from one of the most ambitious industrial experiments in history, an experiment that would astonish the world, terrify enemy intelligence, and forever change the meaning of mass production. When American military planners confronted the enormous demand for heavy bombers in the early years of World War II, they faced a problem unlike anything the aviation industry had ever encountered. Existing aircraft manufacturers such as Consolidated, Boeing, and Douglas could build excellent planes, but not at the scale the war required. Traditional aircraft factories were not designed for the kind of output now demanded by global conflict. The United States needed tens of thousands of bombers, and it needed them faster than any aircraft producer in history had ever delivered. That was when attention turned to one of the most powerful industrial names in America, Ford Motor Company. For decades, Ford had revolutionized manufacturing by perfecting the moving assembly line. Henry Ford had transformed the automobile from a luxury item into a mass-produced machine available to ordinary Americans. His factories had proven that with the right organization, standardization, and workflow, incredibly complex products could be built at unprecedented speed. To many government officials, Ford represented the one company in America capable of applying industrial mass production principles to aircraft. Yet the idea was controversial from the start. Aircraft executives and engineers openly doubted that automobile manufacturing methods could be applied to bombers. Cars, they argued, were simple by comparison. A heavy bomber was not a Model T, it was a precision combat machine requiring exact tolerances, advanced aerodynamics, and highly specialized assembly techniques. Aviation experts warned that trying to mass-produce bombers like cars could lead to dangerous defects and catastrophic failures. Henry Ford himself initially showed little enthusiasm for war production. He had long held isolationist views and was skeptical of deep American involvement in foreign wars. But his son, Edsel Ford, along with senior executives inside the company, recognized both the strategic necessity and industrial challenge of wartime production. As pressure from Washington increased, Ford agreed to take on one of the most ambitious manufacturing contracts in history, producing the consolidated B-24 Liberator heavy bomber. The B-24 was already proving its value in combat. It had longer range than many other Allied bombers, could carry substantial bomb loads, and was versatile enough for missions in Europe, North Africa, and the Pacific. But it was also one of the most complicated aircraft in the world to manufacture. Each bomber consisted of roughly 1.5 million individual parts. Building them in massive numbers would require not just a factory, but an industrial ecosystem unlike anything ever attempted. Ford's answer was radical. If the existing aircraft plants were too small and too slow, then Ford would build an entirely new factory designed from the ground up for bomber mass production. That factory would become known as Willow Run. Construction began in 1941 on farmland near Ypsilanti, Michigan, west of Detroit. The scale of the project was staggering. The planned facility would be among the largest factories on Earth, so vast that workers reportedly used bicycles just to move across parts of the building. At its peak, the plant covered more than 3.5 million square feet of floor space. Its assembly lines stretched for miles, winding through the building in carefully designed paths to maximize efficiency. One famous story, often repeated, though partly simplified over time, claimed the factory's unusual shape resulted from the need to avoid crossing a county line because tax regulations differed between jurisdictions. Whether entirely true or not, the plant's layout became legendary. A sprawling, angular industrial maze built for one purpose alone, turning raw materials into bombers at unprecedented speed. But constructing the factory was only the beginning. Ford's engineers now faced an even greater challenge, adapting bomber production to assembly line principles. Unlike automobiles, aircraft manufacturers traditionally built planes in sections by teams of specialized craftsmen. The process was slow and labor-intensive. Ford sought to break bomber construction into repeatable, standardized tasks that could be performed continuously by thousands of workers along a moving line. To do that, Ford had to re-engineer not the B-24 itself, but the entire manufacturing process around it. Thousands of suppliers had to be coordinated nationwide to deliver parts on exact schedules. Components had to arrive in proper sequence. Specialized tooling had to be designed for every stage of assembly. Workers, many with no prior aviation experience, had to be trained rapidly. New quality control systems were introduced to ensure that mass production would not compromise safety. The difficulties were immense. Early production at Willow Run was plagued by delays, engineering conflicts, labor shortages, supplier bottlenecks, and friction between Ford engineers and consolidated aircraft designers. Aircraft blueprints often required revisions. Parts from different suppliers did not always fit perfectly. Workers unfamiliar with aircraft manufacturing had to learn precision techniques under wartime pressure. For months, critics pointed to these struggles as proof that Ford's bomber experiment was failing. Some in Washington feared the entire project had been a mistake. But Ford persisted. Engineers refined workflows, supply chains improved, training programs expanded, bottlenecks were systematically eliminated, production techniques were adjusted and optimized. Slowly, the chaos of startup began to transform into coordinated industrial rhythm. Meanwhile, Willow Run became a symbol of America's wartime mobilization. Tens of thousands of workers poured into Michigan from across the country. Many were women entering industrial labor for the first time in large numbers, becoming part of the broader cultural image later associated with Rosie the Riveter. Housing shortages emerged as nearby communities struggled to absorb the population boom. Roads, utilities, and infrastructure expanded rapidly to support the growing industrial city surrounding the plant. By 1943, Willow Run was beginning to deliver on its promise. Bombers moved through the assembly line in increasingly smooth progression. What had once taken weeks of specialized construction was being compressed into a streamlined industrial process. Aircraft sections advanced station by station as workers installed wiring, hydraulics, engines, armament, control systems, and structural components with increasing efficiency. The dream of building bombers like automobiles was becoming reality. And as output accelerated, the world began to take notice. Enemy intelligence monitored American industrial expansion closely. German analysts who had once dismissed U.S. wartime production targets as propaganda now received alarming reports from spies and reconnaissance channels. The numbers emerging from American factories, especially from Ford's giant bomber plant, seemed almost unbelievable. The United States was not merely building aircraft. It was industrializing war itself. Ford had taken the principles that once produced family automobiles and applied them to one of the most sophisticated weapons systems of the age. In doing so, the company was helping transform American industry into the engine of Allied victory. What many had called impossible was now underway. A civilian automobile giant had entered the war machine, and its factories were beginning to produce destruction on a scale no enemy had anticipated. Soon, the world would witness just how far that industrial miracle could go. By the time production at Willow Run began to stabilize, the factory had already become one of the most extraordinary industrial experiments in modern history. What Ford Motor Company was attempting inside that vast Michigan complex had never been done before, to mass-produce one of the most complex machines on Earth, the consolidated B-24 Liberator, as if it were an automobile rolling off an assembly line. The challenge bordered on absurd. A B-24 Liberator was not simply a large airplane. It was a flying fortress of engineering complexity. Each bomber contained approximately 1.5 million individual parts. Thousands of rivets held together its aluminum skin and structural frame. Its wings stretched 110 feet. 4 Pratt & Whitney radial engines powered the aircraft across oceans and continents. It carried bombs, machine guns, armor plating, navigation systems, oxygen equipment, hydraulics, electronics, fuel systems, landing gear, and miles upon miles of wiring. Every component had to function flawlessly under combat conditions thousands of feet above enemy territory. Under traditional manufacturing methods, aircraft were assembled slowly by teams of skilled specialists who built major sections largely by hand. But Ford's engineers believed that if bombers could be broken into standardized assembly steps, just like automobiles, production speed could be multiplied dramatically. To make that possible, the entire B-24 manufacturing process had to be reinvented. At Willow Run, bomber construction was divided into hundreds of carefully sequenced operations. Instead of one team building an aircraft in place, the bomber moved continuously through a vast assembly network. Workers at each station performed specialized, repeatable tasks before the aircraft advanced to the next position. One team installed wing spars, another mounted hydraulic systems, another attached electrical harnesses. Others fitted engines, turrets, landing gear, flight controls, and instrumentation. The process was organized with military precision. But organizing the assembly line was only half the battle. To keep production moving, Ford had to coordinate one of the most sophisticated supply chains ever created. Thousands of subcontractors across the United States produced parts for Willow Run, everything from rivets and bolts to propellers and engine assemblies. These components had to arrive not merely in bulk, but in the exact sequence needed for installation. A delay in one shipment could disrupt the entire line. A flaw in one part could halt production for multiple aircraft. Ford's logistical planners essentially built a nationwide industrial network dedicated to feeding Willow Run. Even then, the early months were chaotic. Many parts supplied by outside contractors did not fit perfectly. Engineering tolerances varied. Aircraft blueprints were frequently updated as design improvements were introduced. Workers often discovered that components from one supplier would not align properly with assemblies from another. Entire sections sometimes had to be reworked on the factory floor. At one point, unfinished aircraft accumulated in the plant because critical parts had not arrived or required redesign. The workforce itself posed another challenge. Willow Run employed tens of thousands of workers, many of whom had never built an aircraft or worked in heavy industry before. Farmers, clerks, housewives, students, and laborers from every corner of America arrived to join the war effort. They had to be trained rapidly in precision manufacturing, aviation tolerances, and specialized assembly procedures. Mistakes could not simply be patched over. A poorly installed part might mean the loss of a bomber and its crew in combat. Ford responded with relentless process improvement. Engineers studied workflow constantly, searching for inefficiencies. Stations were rearranged to reduce wasted motion. Tools were redesigned for faster use. Supply routes inside the factory were optimized. Supervisors tracked recurring errors and adjusted training programs. Quality control inspectors monitored aircraft at every stage of assembly. Bit by bit, the line became smoother, faster, and more reliable. Then came the breakthrough. As 1943 progressed, Willow Run's production surged dramatically. Aircraft that once took weeks to complete began moving through the line in days. The factory started delivering complete bombers at a pace previously thought impossible. In its most famous achievement, Willow Run eventually reached a production rhythm approaching one completed B-24 every 63 minutes. The figure astonished the world. To many observers, it sounded impossible, almost like wartime propaganda. How could a machine with 1.5 million parts, larger than many houses, armed for combat, and built to survive anti-aircraft fire, be produced at such speed? The answer lay not in a single miracle, but in the disciplined coordination of industrial systems at unprecedented scale. At peak efficiency, Willow Run employed more than 40,000 workers. The factory ran around the clock in multiple shifts. Raw aluminum entered one end of the plant. Completed bombers rolled out the other. Newly assembled aircraft were towed to adjacent airfields, tested, and flown away to join the war, sometimes within hours of completion. The sheer scale of the operation was breathtaking. Pilots and visitors who toured the facility described endless lines of partially assembled bombers stretching across the floor in every direction. The sound of riveting hammers, machinery, engines, and thousands of workers filled the building day and night. It was less a factory than a mechanical city devoted entirely to manufacturing war. Yet even at its peak, the work remained dangerous and exhausting. Industrial accidents were common in wartime factories nationwide. Workers labored long shifts under intense pressure. Fatigue, noise, heat, and stress were constant companions. Production quotas were relentless because every bomber delayed meant fewer aircraft over Europe and the Pacific. The workers understood that the planes they built would soon carry American and Allied crews into combat, and that lives depended on their precision. And those bombers mattered. B-24 Liberators produced at Willow Run flew in every major theater of World War II. They bombed German industrial centers, hunted U-boats in the Atlantic, struck Japanese targets in the Pacific, transporting cargo, conducted reconnaissance, and supported ground offensives across multiple continents. The aircraft became one of the most heavily produced bombers in history, with more than 18,000 built overall during the war. Willow Run alone produced thousands. More importantly, the factory proved something revolutionary. Even the most sophisticated machines of modern warfare could be mass-produced on an industrial scale if engineering, logistics, labor, and management were coordinated effectively enough. Ford had not simply built bombers. It had transformed aircraft production forever. What many aviation experts had declared impossible was now undeniable reality. The assembly line had conquered the skies just as it had once conquered the automobile market. And as the output numbers climbed, enemy observers began to understand the terrifying implication. The United States was no longer merely participating in the war. It was overwhelming the Axis powers with industrial force beyond anything they had imagined. Soon, reports of Willow Run's production would reach German intelligence, and the reaction inside the Nazi leadership would be one of disbelief, fear, and grim realization. As Ford's Willow Run plant accelerated toward full production, the impact of its output extended far beyond the factory floor. The bombers rolling out of Michigan were not just weapons, they were evidence of something far more dangerous to America's enemies. The United States had unlocked a scale of industrial warfare that threatened to overwhelm the Axis powers entirely. And as reports of American production numbers spread across the world, nowhere were they received with more alarm than inside Nazi Germany. At first, many German officials refused to believe the figures. Before the war, much of Europe had underestimated American military potential. The United States was often viewed by Axis planners as wealthy but soft, a nation with industrial resources, yes, but lacking the discipline, urgency, and militarization of Germany's war economy. Nazi propaganda frequently portrayed America as a society of consumers, not warriors. German leaders assumed that even if the United States entered the war, mobilizing its industry for large-scale combat would take years. They were wrong. As early as 1942, German intelligence services began receiving increasingly troubling reports from agents, diplomatic contacts, industrial observers, and open-source publications regarding U.S. wartime production. American newspapers openly celebrated factory output. Government officials announced ambitious manufacturing targets. Journalists toured war plants and described assembly lines operating on a scale almost impossible to imagine. Axis intelligence officers initially suspected exaggeration or propaganda. Then more evidence arrived. Reports from spies, neutral diplomats, businessmen, and foreign observers painted a consistent picture. American factories were producing ships, tanks, trucks, guns, and aircraft in quantities unlike anything previously seen in modern war. The figures emerging from bomber production in particular were deeply unsettling. Willow Run's massive output, and the claim that Ford was producing a heavy bomber roughly every hour, seemed beyond belief. According to multiple wartime accounts, some German officials and intelligence analysts initially dismissed these reports outright. The idea that a four-engine bomber with over 1 million parts could be mass-produced at automobile speed contradicted conventional assumptions about aviation manufacturing. German aircraft production remained comparatively decentralized and labor-intensive, often relying on highly skilled craftsmen, dispersed subcontracting, and slower assembly methods. Even Germany's most advanced industrial planners struggled to comprehend the efficiency being reported from American factories. But as Allied bombing raids intensified over Europe, disbelief became impossible. Wave after wave of American heavy bombers began appearing over occupied Europe and the German homeland. B-17s and B-24s filled the skies in formations of unprecedented scale. German fighter pilots and anti-aircraft crews watched hundreds, sometimes more than 1,000, Allied bombers approach in coordinated daylight raids. Even when Luftwaffe defenses shot many down, more always came. And then more after that. To German commanders, the most terrifying realization was not that the Allies had many bombers, but that losses which would cripple other nations barely slowed American production. Bombers destroyed over Germany were replaced almost as fast as they were lost. Entire air fleets seemed to regenerate continuously. Albert Speer, Germany's Minister of Armaments and War Production, later wrote extensively about the psychological impact of American industrial output on Nazi leadership. Speer understood better than most that modern war had become a contest of production capacity. He recognized that no tactical brilliance, no battlefield victory, and no temporary operational success could compensate for an enemy capable of replacing men and machines faster than Germany could destroy them. For Speer and others inside the German High Command, American bomber production represented a strategic nightmare. German reconnaissance and intelligence efforts tried to assess the scale of U.S. industrial capacity more accurately. Reports from neutral nations, intercepted communications, and industrial estimates all pointed toward the same conclusion. America's war economy was not merely large, it was operating at a level beyond anything the Axis could match. U.S. factories were producing aircraft by the tens of thousands, ships in record time, and vehicles in numbers so vast they dwarfed German output. Willow Run became one of the most cited symbols of that industrial might. Whether every German report about the plant was perfectly accurate mattered less than the perception it created. To enemy analysts, the factory represented something profoundly disturbing. America had taken consumer-era industrial mass production and converted it into a machine for strategic destruction. The same assembly line principles once used to flood the world with automobiles were now flooding battlefields with bombers. The psychological effect reached beyond Germany. Allied nations also watched American production with amazement. British and Soviet leaders, long battered by years of war before the U.S. entered the conflict, recognized that American industrial mobilization had fundamentally changed the strategic balance. Prime Minister Winston Churchill praised the enormous contribution of American manufacturing to the Allied war effort. Soviet officials, whose armies were bleeding on the Eastern Front, depended heavily on U.S. industrial aid through Lend-Lease shipments of trucks, locomotives, food, aircraft, and raw materials. Around the world, America's factories had become a weapon in themselves. By 1944, the consequences were impossible to ignore. Allied strategic bombing campaigns intensified month after month, striking German oil production, transportation networks, factories, and military infrastructure. Bombers built in places like Willow Run played a direct role in systematically weakening the Nazi war machine. Every aircraft destroyed on the ground, every rail yard shattered, every refinery burned, and every industrial delay imposed on Germany traced back in part to the vast manufacturing power of the United States. German planners increasingly understood the grim truth. Even if Germany won battles, even if it delayed Allied offensives, even if new weapons temporarily shifted tactical situations, America's industrial output meant the broader war of attrition was becoming unwinnable. The Axis could not destroy Allied material as fast as it was being replaced. Every month the war continued, widened the gap further. In many ways, that realization marked one of the war's true turning points. Not a single battle, but the moment Germany understood it was confronting an enemy with nearly limitless industrial depth. The bombers over Europe were not just aircraft. They were flying proof that the economic and manufacturing power of the United States had entered the war in full force. And for German intelligence officers, military planners, and Nazi leadership alike, the sight of endless American bombers crossing the Spies carried a message more chilling than any propaganda broadcast. Germany was no longer fighting merely armies. It was fighting the industrial output of an entire continent-sized superpower and losing. By the final years of World War II, the outcome of the conflict was increasingly shaped not only by generals and soldiers, but by factory workers, engineers, machinists, and assembly line operators thousands of miles from the front. The United States had become exactly what President Franklin D. Roosevelt promised in 1940, the arsenal of democracy. And nowhere was that transformation more visible than in the endless stream of bombers, tanks, ships, trucks, and ammunition pouring from American factories. Willow Run stood as one of the most dramatic symbols of that industrial revolution. What began as a bold and controversial experiment had become one of the greatest manufacturing achievements in history. Ford's massive bomber plant proved that even the most sophisticated weapons systems could be built on a true assembly line when industrial processes were organized with enough precision and scale. By war's end, the Willow Run facility had produced thousands of B-24 Liberators, helping make the aircraft the most produced American heavy bomber of the war. But the plant's true significance went beyond the number of bombers it built. Willow Run represented a complete transformation in how modern nations understood war production. Before World War II, military manufacturing had often relied on specialized factories, skilled craftsmen, and relatively limited production runs. After Willow Run, it became clear that industrial warfare had entered a new age, one in which victory could belong to the nation capable of combining engineering, logistics, labor, and mass production most effectively. The consequences were global. American industrial output during World War II dwarfed that of every other combatant. Between 1940 and 1945, the United States produced roughly 300,000 military aircraft, more than 80,000 tanks, over 2 million military trucks, and thousands of warships and landing craft. These weapons did not merely equip American forces. They armed allies across the world through Lend-Lease, sustained multinational offensives, and ensured that nearly every major Allied campaign was backed by a constant flood of material. This overwhelming output changed the strategic logic of the war itself. Germany and Japan had planned many of their early campaigns around the assumption that opponents could be shocked into defeat before mobilizing fully. Blitzkrieg depended on rapid victory. Japan's Pacific strategy aimed to seize territory quickly and force negotiation before America's full strength could be brought to bear. Both strategies failed in part because they underestimated the speed and scale with which the United States could convert its economy into a war machine. By 1944, American industry was producing war material faster than Axis forces could destroy it. Ships sunk in the Atlantic were replaced. Tanks lost in Europe were rebuilt. Aircraft shot down over Germany returned in even greater numbers weeks later. The industrial balance became so lopsided that Axis tactical victories increasingly had little strategic meaning. Yet the arsenal of democracy's legacy was not only military. The wartime industrial boom transformed American society itself. Millions of citizens entered the workforce in new capacities. Women took on industrial jobs in unprecedented numbers, forever reshaping expectations about labor and gender roles. African Americans migrated in large numbers to industrial centers, accelerating demographic and social changes that would influence the post-war civil rights movement. Entire cities expanded around war industries. New technologies, manufacturing techniques, and management systems developed for wartime production later fueled decades of economic growth. The war had accelerated America into a new industrial era. Techniques refined at Willow Run and other war plants, advanced logistics, systems engineering, quality control, modular production, and high-speed assembly methods would influence post-war manufacturing around the world. Industries from aerospace to automotive to consumer electronics adopted lessons first proven under wartime pressure. The concept that extremely complex machines could be mass-produced efficiently became foundational to modern industrial engineering. For Ford Motor Company, Willow Run became a defining chapter in its history. Though the company would return to civilian automobile production after the war, its role in bomber manufacturing demonstrated that private industry could be mobilized on an unprecedented scale for national survival. The partnership between government and industry during the war became a model for future defense production and strategic industrial planning. Military historians still debate battles, commanders, and tactical decisions that shaped World War II, but many agree on one fundamental truth: the Allies did not win solely because of battlefield performance. They won because they could replace losses, sustain long campaigns, and project force globally through industrial superiority. And few places embodied that truth more clearly than Willow Run. The image of a 1.5 million part bomber rolling off an assembly line every 63 minutes captured something larger than manufacturing efficiency. It symbolized the moment industrial capacity itself became one of the most decisive weapons in human history. When German intelligence officers and Nazi leaders learned the true scale of American production, they understood what it meant. The war was no longer a contest of individual battles alone. It had become a struggle between entire economic systems, and the United States had brought to bear productive power beyond anything the Axis could match. Even after the war ended in 1945, the lesson endured. Future conflicts from the Cold War onward would be shaped by the same reality. Technological innovation matters, military strategy matters, battlefield leadership matters, but behind them all stands the power of industry. Nations capable of sustaining logistics, manufacturing advanced systems, and scaling production rapidly hold a decisive strategic advantage. That lesson was written in steel, aluminum, oil, and manpower across the factory floors of wartime America. And so the story of Willow Run is not merely the story of a factory. It is the story of how industrial civilization itself changed the nature of warfare. It is the story of how assembly lines became arsenals. It is the story of how engineers and workers on the home front helped determine the fate of nations. And it is the story of the moment the world realized that America's greatest weapon in World War II was not any single tank, ship, or bomber, but its unmatched ability to build them faster than anyone thought possible.